In this podcast, we're going to look at naming of acids. And the naming of acids really boils down to there's two types of acids we can have. And one of those acids are binary acids, and the other acids are called ternary acids. The binary acids just include one element, and the ternary acids have a polyatomic ion. Okay, so we're going to kind of split it into two, binary and ternary. And acids are pretty easy to recognize because they always begin with H. Okay, so acids begin with hydrogen, right, or H+. So some binary acids, we'll just jot a couple down, HCl, H2S, and we'll do HBr. Alright, so these are all binary compounds. They have hydrogen with some kind of anion, okay? We know they're acids because they begin with hydrogen. So you might look at this and just go, oh, that's easy, that's hydrogen chloride. Well, that's not really hydrogen chloride. We're going to call it some kind of acid, okay? So each of these are going to start off as hydro something. Hydro, hydro, hydro. Alright, and for the chlorine, it's going to become hydrochloric acid. And the S is going to become hydrosulfuric acid. And the bromine is going to become hydrobromic acid. Alright, so kind of just to summarize naming, if we have binary compounds, we're going to add the prefix hydro, and then it's going to be followed by the root of our anion, and then followed with ic. And we're going to end that up with acid. Okay? So HI would be hydroiodic acid, HF, hydrofluoric acid, and so on and so forth. And there's not many binary acids because you can't put H with that many nonmetals. Alright? So the acids that we hear about more often are going to be, I'll kind of put a list over here. H2SO4, and we're going to do H2SO3 as well, kind of see how these work. HNO3, and we'll do CO3, or H2CO3. Alright, so kind of over here, we only had one H with our hydrochloric, because what is chlorine's charge? It's a -1, and hydrogen's a +1, so we just need a 1-to-1 ratio. Similarly, sulfur is a -2, and because hydrogen's a +1, we need 2 of these for every 1 sulfur. So likewise over here, with our ternary acids, they always have a polyatomic ion. So it's really just hydrogen followed by a polyatomic. And ternary really just means 3. So each of these have 3 elements instead of just 2. In this first case we have H's, we have S's, we have O's. So again, sulfate's charge is a -2. H is always a +1, so that's where we have 2 hydrogens for every sulfate. Similarly, sulfite is a -2, so we have 2 hydrogens. Nitrate, though, is a -1, so we just have 1 hydrogen. And then carbonate's a -2, so we have 2 hydrogens because of our charge. And we always have to balance charges, alright, with ionic compounds. So in this case, for this first one, if we have a ternary compound, we don't need to use the prefix hydro. We're just going to write these down. This first one is called sulfuric acid. Alright, and this is the acid that's found in car batteries. The next one is going to be sulfurous acid. The next one is nitric acid. And our last one is carbonic acid. And carbonic acid is what is typically in Cokes, sodas, stuff like that. Alright, it makes the fizz. Alright, it releases carbon dioxide. So these, kind of as naming goes, we don't use the prefix hydro. I mentioned that already. And then our root stems from our polyatomic ion. So what we're going to do to the right of each of these names is we're going to write down the polyatomic ion that it comes from. So sulfuric acid is really just H with the sulfate ion. H2SO3 is sulfite ion. Nitric acid comes from the nitrate ion. And lastly, carbonic acid comes from the carbonate polyatomic ion. Right, and it's just each of these polyatomics with hydrogen. So in this case, what we really see is that there's no hydro, and polyatomic ions that end in 8. Okay? So 8 ending polyatomic ions become ic ending acids. So notice sulfate becomes sulfuric acid, nitrate becomes nitric acid, and carbonate becomes carbonic acid. And then the other thing we find is that ite ending polyatomic ions end in us acids. So our one example up here was sulfite is sulfurous acid. If I write this one, HNO2, and ask you to name that, well, we know it's an acid. It begins with an H, so we can just kind of go over here and put acid real quick. And it's a polyatomic ion. Okay, so it's a polyatomic ion NO2 minus 1. So if we look that up, or hopefully you have that memorized, it's nitrite. So because it's nitrite, we're going to change it from nitrite to nitrous. That's simply nitrous acid. So again, kind of in summary, binary compounds get the root hydro, the root of the element or the anion, and then end in ic acid. If we have ternary acids, which just have a polyatomic ion, we use the polyatomic ion name to inform what we name the acid. Ates become ics, and ites become us's. And that is how we name acids.